and some of them already sent their questions, and I will be asking them.
Good.
Once we complete the first part of our interview. So the format of the task will be as agreed. So you'll be presenting yourself, just 1 minute, very quick introduction, and then there will be your talk for about 10 minutes, and then question answer sessions.
Great.
As I already warned everyone, it will be more like a live talk to you, answering questions, and as interactive as possible, not a lecture style.
All right, but will some of the students be asking questions directly, or are you going to be asking all the questions for them? Be nice to hear their voices.
Yeah, sure, no problem. I will ask students to ask questions directly as long as we have the proper connection in our classes.
Good. What's it like in Uzbekistan at the moment? Do you have a lot of infections? I didn't look up the number.
In terms of COVID-19, the situation is stable. Of course, now with the new strain of coronavirus, Omicron, we have also increased our restrictions in terms of mask wearing and so forth, also in our school. Now we see the last 2 weeks numbers are increasing, but generally the situation is stable. We can't see that all hospitals are overwhelmed or crowded, so that's not the case.
Good. Are you testing students for virus?
First of all, we have the vaccine mandate in our country. So the vaccine is important for all students who are applying to school, because we have to care about the health of our students, first of all.
Sure.
And in terms of testing, just a second.
I can't hear you. I think you've muted yourself.
Oh, I'm sorry. So in terms of the coronavirus situation, it's quite stable. Now we have the outbreak of seasonal flu. And it seems like we can't distinguish seasonal.
Yeah, it's hard. Yeah, it's hard. But I was asking whether the students are getting routinely screened by testing.
The thing is, the testing itself is a little expensive here in our country, so we can't.
Well, look, even at my school at Cornell, at the medical school, we're not testing people routinely, and that's terrible in my view. We could afford it. It's just not being done. Maybe we should, is it time for us to swing into action?
Yes.
Yeah, okay.
I do believe so. Let's wait for, do they include, now there will be video turn on our classes, on our science class, then we can start. Kamran, are you joining us? Can you please confirm that you can hear us? I'm talking to the class, sorry, sir.
Yeah, no.
Can you please confirm that you can hear us?
Yes, we're hearing you.
Okay, can you share video as well so we can?
Seems like we have got some technical problems.
Я в любом случае нашла. Sorry, we are having technical problems in our class. They are now fixing their cameras, but I can confirm that for now they all can hear you properly. They can see you properly. The only thing, we can't see them for a while now, but they will be joining, so we can see classes as well.
Yeah, am I visible?
Yeah, yes. Kamran Bek, can you see Professor?
Yes, we can.
Great.
Okay, the only thing, we can't see your video for a while, but I think we can solve this problem very soon. Okay, let's start then our talk. First of all, I would like to give the stage to honored Professor Harold Varmus. I asked some of our students to read a little about your biography, because your biography was very interesting to our students, particularly the ones who are planning to seek their career in science. Here we are. We can see now the class.
Hello.
For a little while, they are now fixing the problem. So I would like to give turn to Harold Varmus, and it will be good if you make a very quick introduction of yourself, but many of our students already read your biography, and then a 10-minute talk. So Professor, you can start.
Well, thank you very much, Mr. Soliev, and it's thrilling to be able to speak by Zoom to a place so far away, a place I've never been, but a place that I find extremely interesting to read about. So as I've said to Mr. Soliev, my goal here is just to give you a brief introduction, especially for those who haven't had a chance to look at the memoir that I wrote, and tell you a little bit about myself and where my family comes from, a little bit about how I grew up, and a word or two about some of the science that I've done during my career. The goal here is to interest you in becoming a scientist, and to tell you that there are lots of ways to become a scientist, and not all of them are conventional. That science is an exciting way to interact with the world, and to make yourself useful to other people, at the same time to make your own life interesting and productive. So my family is European in origin. In over 100 years ago, all of my grandparents came from Europe. My father's family came from Poland, around Warsaw. My mother's family came from a place not that far from you, a place that's now near the city of Lvov in the Ukraine. I know it's probably a couple of thousand miles, but not so distant. And they were all encouraged to leave Europe because of prejudice against Jews, and they came to America to seek a brighter future. And indeed, they saw that, because the children, among the children that they had, were my parents. My parents, even though they were first generation Americans, went to very good schools and had professional careers. My mother was a social worker. My father was a family physician. And they lived comfortably on the South Shore of Long Island. Unfortunately, they died in their early 60s, an age that I would now call young. But they were the recipients of a much improved social situation, and that they were not discriminated against as Jews. They went to good colleges, had productive careers, and created a comfortable environment in which my sister and I grew up. And when I was your age, I really didn't think I was going to become a scientist. Like many children who admire their parents, I thought of myself as having a future in the health professions, but imagine myself being, like my father, a family doctor, perhaps a little more involved in teaching and academics, but I really didn't think of myself as being likely to do science. In fact, I went to a high school that was run by the government, a so-called public school, which didn't have good science programs, and there was nothing particularly exciting about what I was seeing as science while I was a high school student. In fact, the most interesting things that I was taught in high school were literature and perhaps some history. And I went off to college not really knowing where education would take me, but I assumed at some point I would be eligible for medical school and go off and become a doctor. My college career, however, was exciting in unanticipated ways. I found myself deeply involved in reading of literature, especially English poetry. During that period, I also was the editor of the school newspaper, became interested in a career in journalism. And while I took my pre-med requirements, I didn't feel in any sense that I was headed for a scientific career. And indeed, I set off after college for some graduate training in literature. During that time, I began to regret not going to medical school, so I turned around and went to medical school. During those days, it was required because of the unfortunate engagement of the United States in a war in Vietnam. It was required that all physicians do government service to be sure that the U.S. Army was adequately equipped with doctors in Vietnam. But it was possible to substitute service in what we call the public health service, either organizations run by the government that did biological science or served the country through its understanding of epidemiology. And I was fortunate, despite my lack of research experience, to be admitted to the service, the agency called the NIH, the National Institutes of Health, which has played a very large role in my life. I'm not sure you can read this, the writing on this mug from which I'm drinking coffee this morning, but I went to serve in the public health service at the NIH under the guidance of an extremely good scientist who's still a very close friend of mine. And I learned how exciting science can be, something I had never seen before during my courses in high school or college. And I began to make discoveries and realized that it's really thrilling to make use of a modern technique to answer long-standing questions about how biological systems work. And after 2 years of a very exciting period at the NIH, I decided I was going to go and try to apply what I had learned there to the study of cancer. There were, at that time, we're talking about 1970, a long time ago from your perspective, but it seems pretty recent to me. But at that time, it was apparent that while cancer was hard to study because we really didn't have much access to the kind of techniques that are now conventional, like DNA sequencing and attempts to understand individual genes. But there were a few methods that were becoming common and could allow an incisive study of how certain viruses were able to cause cancer. One class of viruses that became important in that period, the viruses that we now call the retroviruses, viruses that now include HIV, the causative agent of AIDS. There were many viruses in that class that caused cancers in mice and chickens and other experimental animals. That seemed like a good place to start a scientific career. And I found someone in California with whom I could do that. I started working on the study of those viruses and realized that there were many really terrific questions about how those viruses were able to multiply, and so that one infected cell made thousands or even millions of virus particles, and to understand how a simple virus with only a few genes could cause cancer. That was the starting point for a career that I'm still pursuing at the age of over 80 to try to understand how cancer arises and how viruses grow. And you can see in today's pandemic the importance of understanding how viruses grow. Clearly, every day, people get more and more educated about how the coronaviruses carry out their replication cycle. But it's also possible to see, if you look at what's happening in cancer research, that our discovery of genes that are in the human genome that can undergo mutations to drive cancer is also a very important feature of dealing with a very common set of diseases that we know as cancers. So that part of my career, which I would never have anticipated happening when I was in high school, has been very gratifying. But at the same time, as I got older in science and better known, I began to take on roles as an administrator, and eventually had a chance to run 3 organizations: the National Institutes of Health in general, the whole collection of institutes and centers, the Memorial Sloan Kettering Cancer Center, and then one of the institutes at NIH, the National Cancer Institute. And those two have been gratifying experiences because, in addition to conducting research in my own laboratory, I've been able to direct the activities and engineer the future of major institutions that are carrying out research in cancer care. Today, I conduct research at Cornell Medical School. I teach students there. I teach a course in science and society at colleges in New York, and I do some work for the World Health Organization and so other organizations for which I serve as advisor. So I think that's probably enough background. I'd like to hear what you're thinking about, answer some questions you might have, and generally try to get acquainted and provide whatever answers I can to questions you might have about how careers in science are shaped, how they're productive, the kinds of problems they present, and why you might consider taking on science, even starting in Uzbekistan, but which is a little distant from many of the great centers in science. But nevertheless, all of us have in our laboratories all the time people who come from other countries and have come to some of the centers for science, like New York, London, Boston, and many other places, to find out, to get trained in the conduct of science. Science needs all the brains it can get, and there are as many good brains in Samarkand as there are anywhere else.
Dr. Varmus, Professor Varmus, let me ask some questions as some of the students already written, and then we can give live questions if they have.
Sure, that's good.
First question was about your part of biography. As we know that still learning English is important if we want to succeed in science, because English has become the language of science. And there is one more thing we have to highlight, that's the in your biography, we see that you were involved in English language quite a lot. We see that your bachelor's degree, your master's degree was primarily connected with English language learning. So when we combine these two of your background information, so you are as an English language expert and you are this world-renowned scientist, what would be the top advice in that respect? So
yeah, well, let's
learn English so it can benefit science.
Right. Well, let's start first of all by distinguishing between learning how to read and write English in a very effective way and the experience of studying English literature. So as an undergraduate at Amherst, of course, I was at the college I went to, I arrived knowing how to read and write English pretty well. I was, English is my native language. In fact, one of the things that I'm ashamed of is that I don't really know any other languages. I know a little bit of French and a tiny bit of German, but the studies that I did were not studies about learning to be a good reader and writer of English. However, let's come back to your main point here. The success in science these days, unfortunately, because English is so dominant in the world, is linked, in my experience, to having a real mastery of the English language. And one of the things that I applaud your learning center for is your emphasis on learning English. It may not seem fair. It's a history of colonialism that in part drives the dominance of English in science. So we don't necessarily admire the colonialism that preceded this dominance of English. English is, I think, an outstandingly flexible language with many virtues, but it is only a product of history rather than there's no reason why Chinese or Italian or some other language might not have been what we call the lingua franca, the language most commonly used in science. Indeed, at one time, it was German that was the most commonly used language in science, where you could argue that when science became a popular discipline in China over 2,000 years ago, that Chinese was the major language. But now it's English. And if you want to prosper in science, you really need to master English, because all the important journals are published in English. You can't spend your whole life working with a translator and having everything translated for you. And it is much easier to communicate with your fellows. We have to, maybe a time to emphasize what I think is a very important point about scientists. People sometimes have this idea that scientists are only working by themselves and sitting in a laboratory and trying to understand how the world works. That's not how science works. Science works by having individuals have good ideas, but then to pursue those ideas in the company of other scientists, and very importantly, to have other scientists recognize that the findings of any individual or any group are right. That means confirming studies, building on studies, discussing work. Science is a highly collaborative enterprise in which the findings of science only become effective and real when others accept them. And the process of accepting the work and building on it is a process that depends very heavily on writing your results, promulgating them, that is, spreading them around through journals that are mainly in English, and having other people talk and read about that work. You're muted again, sir.
Thanks a lot. And now the second question of college applicants. Many of our high school students are planning to apply for universities that you have some experience with, Harvard, Columbia, Amherst, and others. And they are Ivy League schools, and it's not very easy to get accepted. So what advice would you give to those students who are pursuing studies in universities so they are not very easy universities to get in, particularly if you live in Uzbekistan. So what advice can you give to?
Well, I don't have any solution to that problem, but I think the obvious things are to do well in your high school and have good grades. That's something that I'm sure everyone understands. I do think it's important to write essays that illustrate your personal strengths. Don't try to satisfy what you think are someone's objectives, but try to state what is motivating your own interest in learning. Explain why you as an individual are particularly keen on attending one college or another. College admission is competitive. Happily, most colleges recognize that college is expensive, and that people who come from relatively poor countries won't be able to afford the tuition. But all the schools that you've mentioned have enough money in their bank account that they are able to pay for students who come from abroad and are the kinds of students that the school would like to have on its campus. I would point out that coming from Uzbekistan, you have one big advantage. Most of us don't know anybody from Uzbekistan. We don't know much about it, but we know it's a big, interesting country, which has had a pivotal role in history of the growth of civilizations, being a major site on the Silk Road. Most students there probably have not been frequently out, if ever, outside of the country. The idea of taking a student who's talented and has had an unusual experience growing up in a place very different from Boston, New York, or San Francisco will make a contribution to campus life. So I think stressing the advantages that you bring to a campus by coming from a place that people may have heard about but don't know much about and have never visited is a way of making American campuses more diverse, more heterogeneous. And right now, there's a lot of emphasis being placed correctly, in my view, on having a high degree of diversity of culture, ethnicity, language, and other things on our campuses so that we understand more about how the world works.
Thank you. And another very quick, I think, question. If you were 17-year-old now, which college would you apply?
Oh, Amherst College, where I went. I still think it's a great place. But I would probably apply to a lot more because I know that the chances of getting in are much less good than they were when I was growing up. I applied, I think, to 6 colleges. My father had gone to Harvard, and even though I wasn't really that excited about going, but I thought I probably had an advantage because my father went there, even though he only went for 2 years because he couldn't afford the last 2 years of college. But when I got in, I didn't go because I preferred what I saw when I went to a smaller college like Amherst to visit. And I applied to a couple of places just as that I thought I would certainly get into. But these days, I know that people apply to 15 or 20 colleges, even if you're here and well-trained in a high-powered American high school. So I don't have real advantages about real insight into that, but I assume that you must have people at your academy who are very experienced in trying to guide your students into good schools, not just in America, but England and other European countries and China and other places that have strong universities.
Yes, sure. For example, now one of our students currently studying in America, he's now doing his high school in America, who joined us, Bob John. He will ask a question, but let me finish some written questions and I will
Sure.
Students. Another question about how to start a scientific work. It's a question from our science club. They have already selected the topic about what they are going to research. It ranges from climate change and environment to the economics, finance, and so forth. But where to start and how to make sure that your research will be compelling enough?
Well, that's a really good question that I think all good scientists think about quite a bit. And a lot of it has to do with an emotional response. That is, if you feel that some aspect of the world is poorly understood, you care about trying to understand it better and perhaps improve life on Earth by understanding things better, you will lean in that direction, that is selecting a topic, a general topic. And I grew up in a medical household. As I mentioned, my father treated patients. He was a family doctor. My mother was a psychiatric social worker. I had some relatives die of cancer. I was interested in disease and how to improve our understanding of disease and improve the way we treat it. Nevertheless, as I also mentioned, initially, I was not thinking about this from the perspective of a scientist. But when I did begin to encounter science as a doctor working at the NIH, I saw that there were questions that very much appealed to me. And I think regardless of what field you choose, whether it's climate change or the need for better sources of energy or some aspect of species diversity, or there are many topics that are obviously of great interest at the moment because of the way the world is being threatened by the way human beings have behaved. Regardless of what area you choose, whether it's health or energy or basic physics, the thing that really helps is to identify a question that you want to answer. And then choosing the way you want to answer it depends very heavily on your own skills, the development of technologies that allow questions to be answered. But defining what the question is really critical. These days, especially in biology, there are new tools for generating data. And there are people who say to themselves, well, with this new tool, I can generate a lot of data. To me, that is much less appealing than saying, here's a question that I'd like to answer. And this question is going to drive how I proceed, because I really want to know the answer to the question. And you may think that's a hard thing to have happen, but once you say, here's a topic I'd like to study, and you go to work in someone's laboratory, in the laboratory of somebody who has been successful in that area, you will begin to see what the important questions are. And those questions are those that are just ahead of what we know and are susceptible to being answered because we have new tools that allow answers to be obtained to questions that may have been difficult in the past. Certainly, in my own career, some of the questions that I worked on are questions that existed long ago, but weren't approachable because the techniques for trying to answer them weren't available. And being passionate about a question and being alert to the technical possibilities of answering the questions is something that frequently accounts for success in science.
Okay, the next question is about also from Science Club. We know that the data collection is an important part of any research. So what resources can you suggest where to start if a researcher, if future researcher or a student is starting data collection, where they should start looking for?
Well, I don't think I would start anything by looking for data collections. I think what you really want to start with is the question you're trying to answer. Data collection and data sharing are very important parts of science, and sometimes very contentious parts of science, because on the one hand, people want their data to be collected and stored in a good place and integrated into the other data that other people have collected. But people also feel protective of their own data and don't want sometimes take a negative attitude toward having other people work on your own data and draw conclusions from data that you've generated. My own bias has been very strongly in favor of sharing everything, the animals you work with, if you're doing animal research, the results you obtain, the data that you want to put into a database, because first of all, we're paid to do science by various kinds of donors, by governments, by wealthy people, by organizations, frequently organizations run by people who are concerned about the prevalence of disease. And we are, as beneficiaries of that kind of generosity that allows us to do this exciting work, we owe it to society to provide our results in a free manner. Secondly, and perhaps even easier to understand, people care very much about their reputation as a scientist, about how you behave as a citizen of the scientific community. And everybody admires someone who is generous and who provides their results for others to look at and to analyze and to use. Furthermore, if you don't allow your data and your materials to be used, people don't know who you are. And the result is that you're a silent, anonymous scientist whose results are not part of the mainstream. Science is, as I mentioned before, an interesting combination of individual work, the work of the individual imagination that thinks through problems, but it also works as a community. And being a generous and interactive member of that community is one of the necessities and pleasures of being a scientist.
Okay, thank you. And also a very quick question. who is the most admirable researcher or scientist in history, in your opinion?
Oh, I really can't answer that question. I think, first of all, people are too complicated. There are people I admire tremendously who have also shown that they have some severe blemishes. An obvious example is James Watson, who I admire from many points of view, but has also said a number of things about women and people of color that have made him despised by many people. So, it's very difficult to make a simple judgment. People are complex. And I think it's unfair to say that one person is the most reputable, best scientist who ever lived. I think we all live in the shadow of Charles Darwin. There's some people who say, well, Darwin didn't do enough to acknowledge the similar conclusions drawn by some of his competitors, or that he had certain beliefs that might have been the beliefs of a 19th century wealthy Englishman, and we don't admire those. But Darwin was both a brilliant writer, a very insightful observer, and someone who could synthesize many observations into major laws of nature. And we all do everything we do as biologists in the light of Darwin's ideas about evolution. And I think it's very hard, regardless of what you think about every aspect of his life and character, to deny his powerful hold on the thinking of everybody. I mean, look at what we're doing today with trying to understand the evolution of this pandemic, the COVID pandemic. Right now, the most discussion I hear is focused on how viruses evolve, what the rules of selection are, what attributes of the virus or of the human hosts are influential in shaping the next stages of the pandemic. So Darwin would be very pleased to see how much his thinking about the origin of species is affecting the way we think about the evolution of this pandemic.
Thank you. And what is your most significant achievement?
I don't think about things that way. There are things I enjoyed doing. There's no doubt that I have to face the fact that the discovery for which my colleague Mike Bishop and I received the Nobel Prize in 1989 is the thing that we're most known for, which is the discovery of cellular oncogenes using the cancer-causing genes found in retroviruses as a means of discovering the cellular genes. And that is that is what we'll be known for 100 years from now, if we're even known at all. But I got more pleasure from other kinds of discoveries, some of them not that well known, but discoveries that involve very clever experiments, that involve working with particularly brilliant students, discoveries that were completely surprising to everybody, or discoveries that just helped to unite some discrepant findings and allowed us to see that the answer to a question was not what we thought it would be, but something surprising and maybe even beautiful.
Okay, now about entrepreneurship. Many of our students are also admiring to become entrepreneurship, and now, the science and entrepreneurship, science and business are connected. And we also see your biography that you are connected with some of the greatest entrepreneurs of our time, like Bill Gates or Mark Zuckerberg. Can you please quickly characterize them, and what do you think about entrepreneurship and science?
Well, yeah. No, my connections, I'm not myself an entrepreneur. I've never started a company, but I've worked with many companies as an advisor, and I've enjoyed it. I was fortunate to be at the University of California, San Francisco, at a time when some of the first biotech companies, Genentech, Cedis, Chiron, and others were founded. And I've either served as an advisor to some of them or had friends who worked closely with those companies. I consult for several companies now, and I've always enjoyed that experience. A lot of great science has been done at those companies, and terrific products have been made, especially by companies like Genentech. The people you mentioned, it's interesting. You mentioned Bill Gates and Mark Zuckerberg, both of whom I've come to know because I've been a consultant for their foundations. But they have been entrepreneurs in a different world, in the world of computation and software. And that has not been the nature of my relationship with them. I've been consulting for their foundations, which do frequently adventurous and important work. But the relationships are complicated because I don't approve of everything that Facebook is doing, for sure. So that there are tensions created by having a complicated view of people who have also done some great things in supporting research and supporting research in very interesting ways. The kind of entrepreneurship that I find most intriguing, however, is the kind that results from someone in an academic institution making a discovery that might be capable of leading to a new way to practice medicine, to develop a drug or a new diagnostic procedure or some kind of new imaging method. Seeing someone who's young, who's made a discovery, who suddenly sees the opportunity to turn that discovery in basic science into something that will benefit human beings and their desire to escape or recover from disease can be quite thrilling. It's an adventure. It's money on the line, good science in play, and the possibility of great benefits to patients as part of the formula.
Thank you. Now, I would like to give a short turn to Bobby John, who is joining us online, to ask one question because it appeared he has some other plans. Bobby John, you had a question. Would you like to ask?
Bobby John is the student, or?
Yes,
Yeah.
He's our former student who is now transferred to America.
Transferred to America. I see American flag in the background, unless
Yeah.
you've got red and white stripes on your flag in Uzbekistan.
No, it's the American flag.
Where are you?
So right now I'm at James Madison High School in Brooklyn, New York.
Uh-huh.
And I'm a senior, so I've been applying to colleges. So my question was about, so you've been to like Ivy League, non-Ivy Leagues, you've been to different campuses, and you know how competitive right now these Ivy Leagues or these prestigious universities have gotten. And do you think the environment is different, or the quality of education differs from these universities from your experience?
I'm not sure what you mean by different.
Like, I mean,
I went to college over 60 years ago. Things have changed, but of course, as you say, I visit these campuses all the time. I teach at CUNY, you know about CUNY, if you're in New York, and I teach at Cornell, obviously, and these places are good. I don't think being in the Ivy League is not, as opposed to not being in the Ivy League, make a huge difference. But I think the only way to find out something about how you're going to respond is to go and visit those campuses and get some idea of what's going on, speak to people who are there. Ultimately, the only way to really find out whether you like a place is to go, and you're gonna have to make some choices on incomplete information. But it sounds as though the places you're looking at are all distinguished. And, I went to Amherst College and I had a wonderful time there, but there were people who were, quite similar to me in my class who were very unhappy. And I think it's just very difficult to predict how any single individual is going to respond to any particular college. It depends on the friends you make, the courses you choose, the professors you happen to encounter in the classroom. May depend on the state of the world or what's happening in your own social life. So I just think it's very difficult to do more than say, here are a bunch of schools that I think I could be happy attending. and then choose one and do the best you can to take advantage of it. And there, I think, I think the choice of one school over another, if you're comparing, say, Columbia to Harvard to University of Michigan, is not which school should I go to. The more important thing is, what do I do when I get there? And what kinds of courses do I take? How do I find out who the interesting professors are? How do I come to understand myself and my own desires to take full advantage? All these schools have incredible resources, books, professors, smart fellow students, and smart fellow students is very important. I think one of the main reasons to go to a highly competitive school is not because the faculty will be so much better, but because the other students will be better and more ambitious and perhaps more talented.
Got it. I just have one more question. You mentioned earlier how it was not until you went to graduate school that you decided to do medicine and all that. So for us, the younger generation, what is your advice on how we should approach what we want to do? What if we're not sure about what we want to pursue in the future? What if we're like, oh, I want to do this, but I also want to go and possibly explore this. So what is your take on this?
Well, look, I can't tell you what you should do. Only you can figure that out. But the one point I repeatedly make, people are bored hearing me say this, is that life is pretty long and you don't need to make every decision when you're a high school senior or a college senior. You can make decisions later. And, I think one of the things I like to say about my own early career is that I had what some people would call a very long adolescence. I was, uncertain about what I really wanted to do, really until I got to NIH and I was almost 30 years old. So you want to keep doors open. That means not closing the doors on certain things you think you might want to work on for a long period of time, and look for opportunities to learn more about things that have caught your interest. And I think that depends on your ability to decide who's telling you interesting things, where the prospects for growth of a scholarly field is likely to occur. But you got to listen to your own internal sense of what looks interesting and exciting to make an ultimate decision. But in general, there's no need to rush things. And I see that in contrast to my own generation, which tended to go into a profession directly after college, many more students these days are taking 1 or 2 or 3 years off from traditional learning and just working in a lab or going abroad, exposing oneself to totally new experiences and trying to figure out what makes them happy and what they find stimulating. So I would just relax about it. It's good to go off to college after high school, though some people take a year off then as well. But getting an international experience, which is certainly what you've had, how old were you when you left Uzbekistan?
I was about 10.
So you were pretty young, but now you've had an American experience. Maybe you should think about going to college in the UK. I don't know, but diversifying your political and geographical experience is, in some ways, just as important as diversifying your academic experience.
Okay, thank you so much.
Okay, thank you. Now I would like to give turn to our audience. I think they have some questions. Kamran, can you please ask a student from audience to approach the microphone and come closer to microphone and ask a question?
Yes, we have one question. Can you hear us?
Yes, we can.
How many women and men are in your school? Looks like a lot of men in that room.
The only thing is the late time. We have still very Eastern country, and sometimes ladies are not allowed too late because it's 7 p.m. our time. the time we started. But we have about 40 students watching us via YouTube, because another problem we have here is the internet connection. It might not be very good. So
Yeah.
they-
No, I'm
they
just curious about whether you have an equal number of men and women in school, girls and boys in school.
55% of male and 45% of female.
Good.
I
Okay.
don't think it's a very big difference.
Yeah,
So-
but the view I have of that classroom is male dominant.
Okay, Kamranbek, would you like to go ahead and ask question?
Yes, we have a question from the student of Medical Institute. So here he is.
Hello, Professor. My name is Azizbek. I'm a second-year medical student. And for the time being, in my curriculum, there are subjects, only general medical subjects like anatomy, physiology, microbiology, histology, and so forth. So I don't know where to go further, which specialty to choose when I graduate my bachelor's. I'm attracted by the spheres in medicine that are obscure, that haven't been studied in depth. So what is and will be in the nearest future the most research demanding sphere in medicine, in your opinion?
Well, look, I don't try to predict what's going to happen in the future, but I think if I were starting out these days, I would say that the neurosciences are probably going to be the most interesting and productive over the next 30 or 40 years. But that's only a guess, and there's still a lot to learn in the world of cancer research and oncology. A lot to learn about developmental biology and how it applies to the generation of highly functional human beings. I think I don't think there's an area of medicine that is fully flowered yet, and certainly learning new ways to image the inside of a human body, to make use of genomic technologies. At the moment, I'm involved with work at the WHO, the World Health Organization, to try to make genomics more useful for people, especially people in developing countries. And there, the emphasis may be less on discovery than on application, but there are many important things to do to make a technique like the analysis of human and microbial genomes more useful to human beings everywhere in the world. So I think, there's no simple answer to your question that applies to everybody, which is why I don't like giving this kind of advice, because one person's answer is not the next person's answer. And I think you simply need, every medical school, whether it's in Uzbekistan or the US, begins with broad topics. You've got to learn what microbes are and what the most important are in medicine, no matter where you're studying. And the way in which you develop a research interest and a specialty is by finding some questions particularly interesting to you. And happily, not everybody thinks that the same things are interesting. Otherwise, we'd only be working on one problem. But happily, we're all different, and we gravitate toward different topics because of some still poorly understood attractions that one field has for one person. There's interesting things to be done in every area. We're still very far from curing most forms of blindness, for example, and yet there are clinical trials going on to try to repair the genetic deficiencies that lead to diseases like retinitis pigmentosa, just to give you one example. And yet many people think, well, we have really good ways to measure vision and to do surgery and make glasses that correct vision. But ophthalmology is still a very exciting field. It's one of the places, for example, where gene therapy is being experimented with. So I don't think there's any field that is immune to the idea that a lot of progress can occur, and by doing very exciting work. Go with your own feelings. Don't ask me.
Okay, thank you. And Professor, can we continue with 2 more questions or?
Sure, yeah, we're fine. Yeah.
I know that we agreed in a different timing, so as long as you agree, we can.
Well, for me, it's just morning. You're the ones who are hungry. I've had my breakfast. It's just morning here.
Okay, now.
But I do have to move on to some other things very soon, so, but
Okay.
go ahead.
Okay, one more question connected to your also biography. Your biography says you failed to enter medical school of Harvard twice, and probably that might be, so the students are asking, of course, it's an awkward question, but how did you feel about it? Because any student applying for Ivy League school, they should be ready for any disappointment. So how did you overcome the time when you were, because
well, look, there's more than one medical school. It wasn't so just everyone seems interested in this fact that I was turned down twice by Harvard Medical School. The first time, I think the school made a good decision because I then chose to go to graduate school in English. I wasn't ready for medical school at that point. The second time I applied, I think they did make a mistake. I would I'm bold enough to say that, but Columbia took me in. So at the time I was a little surprised and disappointed, but I knew that there were more than 100 medical schools in the US and at least 20 or 30 of schools I'd like to go to, and I'd find some place eventually. And I was pretty, I think that's a question that's more difficult for someone to answer if they're worried about getting into any school. And I was probably a bit arrogant, having had a good academic record and thinking of myself as someone that a medical school would want. I've always been pretty confident that things would work out. So I'm not somebody who is driven to despair by one rejection. I know there's a certain amount of arbitrary thinking that goes into a decision to accept or reject a student. And, I had a somewhat erratic history. You may recall, if you read that passage, that the admissions officer who talked to me suggested that I go into the Army. Now, that's the last thing someone like me should do. So I was already prepared to say about this person that his judgment wasn't very good. So that definitely diminishes my disappointment by thinking that the person who was making the judgment was not particularly incisive. So I went on, and in the long run, was glad that I went to medical school at Columbia because it allowed me to live in New York, where the cultural life is much richer than it is in Boston. So, and many things happened as a result of going to Columbia that I think you don't want to be overly focused on feeling that one school is the only school that will totally satisfy you.
Yes, there is a very good Eastern proverb, the Uzbek version: if one door closes, then the second opens.
Yeah, well, that sometimes several things open at once, but I agree that one door closes, another the door you wouldn't have gone through, you can now go through. So,
and one more question regarding the internship, as you already mentioned, Samarkand and Uzbekistan, sadly, is not one of the science centers. So, do you run any internships, or we have science clubs? If someone was interested, whether you'll be, if there is an intern who's extremely bright, who's working on themselves, will you be able to accept it anyhow?
Well, I do have students come to my lab. Some years ago, I decided not to take any more graduate students because I simply didn't have the time, because of my other outside activities, to supervise someone who was doing a thesis for a PhD. But I do have students from local schools and some students from the Middle East, because the school I work at has a branch in Qatar, in Doha. And last summer I had a student from Doha in my lab. So it does happen. My lab is small. I don't have very many such students, but I do have some. I take high school students. I have a student now who's at the City University of New York, who's spending a couple of days a week working with us. And most labs in America, especially the large ones, take in high school and college students and medical students to give them a taste of research. It's usually those internships don't provide enough time to complete a project, but it allows you to work in a research environment and to feel what the community of science is like and understand the nature of scientific work, even if you don't get the satisfaction of finishing a project and writing it up for publication, which only is likely to happen if you spend a couple of years in a laboratory. But I certainly encourage internships. I certainly can't promise that I would have one available for a student from Uzbekistan, but there's, it's always possible.
Do you think this internship can be done online? Because I don't
No.
think it will be able to travel.
No, I don't think so. I think we need to get the world adjusted to these coronaviruses because science requires interactions, personal interactions. I don't even like having my own group meet virtually. We need to meet together. We need to go to meetings. We need to travel. We need to form collaborations and friendships. Almost all the important things that have ever happened to me in science have depended on travel, companionship, direct personal interactions. It's a very important part of doing science. And whether it's COVID that's worrying us or the carbon emissions from airplanes, we simply have to say, we're going to reduce the amount of traveling we do and make it all meaningful, but we're not going to stop traveling. You're muted again, I think.
No,
Yeah.
sometimes I mute myself not to disturb you because there can be some background noise and I don't want to disturb your speech. So now, before we finish, I would like to give you a very little thank. We have prepared a specific letter of thanks for you on behalf of our center, as long
Thank
as
you.
you're free to accept. Thank you.
Very nice. Thank you.
Applause from the audience. Applause.
Well, let me applaud the audience for some very good questions, and thank you again for inviting me to do this. This has been interesting, and didn't know about your academy before, and I'm glad to know about it and to see all the good students.
First of all, I'd like to thank you once more for taking time. And as I wrote in our earlier communication, it's such a rare opportunity to speak to world-class scientists in this respect. And we will also be honored if you participate in the graduation ceremony of our students, of course, virtually this time as well. And I also would like to extend our invitation to Uzbekistan, to our lovely city. If at any time of the period when these COVID restrictions are taken back and you would like to, and you can.
I'm not averse to travel. In fact, next week, my wife and I are going to the Nile River to do an archaeological tour of Egypt. So we're traveling.
Wow, that's just fantastic. I would like to ask you to make a little research about our lovely country.
Okay. Well, I have read up on Samarkand. I know how important it was historically, and I've seen even movies of some of your major buildings in the center of the town. So perhaps someday we'll be able to work that out.
Yeah, sure. Just let me know whenever you come. Our students, volunteers will be eager to show you around the city. And as you say, nothing can substitute human-to-human interaction.
Right. Well, I appreciate that. And thank you again for the invitation. Very nice to see you all.
Okay. So
bye.
I'm from Samarkand. So once more, we thank you for your support and for your time to participate and talk to our science students. And
no problem. A pleasure.
Okay. Thanks a lot.
Bye.
Take care, sir.